Well, today is a special treat. We're going to be taking a look inside the Microbot, which was made by TOMY in Japan back in 1965. It's a fairly rare robot that you won't see very often, but you also will probably never see a description of how it works. I'm going to give you a schematic in case you ever have to work on one or want to make your own and what's going on. I'm going to move some of these parts so they don't fall over. You know, the arms and the screws and everything that hold it together. This would be the body back, which would normally go right on there. So we're looking in from the back right now. I'm going to flip it around to the front. There's a ratchet in the wheel. It was not a motorized base. You pulled it with the microphone cord, of which there's lots of length. So here's the front, as you can see. And the on-off switch is over here. So you turn it on. Then you have the microphone. And if you speak into the microphone, your voice or sound will come out of the speaker in the chest. The eyes will light and the mouth should move. Hello, hello. Testing. 1, 2. Test. 1, 2, 3, 4. So that is the functions of it. And the way they were doing all of that back in 1965. I'm trying to grab something here that's going to help the description, I think. Okay. So inside this microphone, there is basically a carbon microphone element. Now this is the same element that's used in old telephones, clear up into the early 1970s. If you unscrewed the mouthpiece, you know, off a telephone receiver that you held that had the mouthpiece and the earpiece, unscrew the mouthpiece, you can pull one of these out. And basically, this is just a metal container that's full of carbon, graphite, and has a diaphragm in there. And the outside is one contact, and the inside is another. And they're very durable. They're hard to break. But mainly they provided a very strong signal, and they were very inexpensive to make. So that's what's inside here, is basically a telephone cartridge. And this was sent to me, obviously, because it wasn't working. And it wasn't working because someone had totally bastardized the very simple circuitry in there. And also there was a mechanical problem with the mouth linkage to a solenoid up on top. But let's just talk about the circuit first. So basically you're starting with, in the base, there are 3 D-cell batteries, and they're D-cells because back in the 60s batteries were mostly carbon batteries, and they didn't have that much current. They weren't good for that long. And this thing is kind of current hungry. The way carbon elements work is you have to bias them on, and you waste current there. This little relay that we're going to talk about in a second is on all the time in varying degrees, so it's drawing current. And then, of course, there's a speaker that's being driven. There's a solenoid up here that moves the mouth, and then there's the light. So there's a lot of things drawing a lot of current for battery technology of the 1960s. So they went with 3 D cells, which gives you 4.5 volts optimum. The negative side is run through the switch on the side, which is over here, like so. And this circle represents that carbon microphone that I just showed you. The main metal outside part is going to be connected to the ground, the common, and the little center button piece is going to have a pull-up resistor, 57 ohms, to the positive 4.5 volts. So already there's a current path going on there, which, you know, doesn't help the battery life any. But they're going to pull a signal off of that. So they went through a capacitor, and because that's pulled up positive, you put the positive side of the capacitor to that center terminal in that resistor. In this case, it's a 10 UF capacitor. And then on the other side of the capacitor, there's a pull-down resistor, 6.5K in this case is what was used inside the device, down to the common rail. This heavy black line's our common rail. And then that's going to go over to a PNP transistor. And like I said, this was sent to me not working, and someone had tried to repair it. The first thing they did wrong is, instead of replacing the original transistor, which may not have been bad, we'll never know, they put in an NPN. They put in a 2N222. which is a NPN transistor. Not going to work in this circuit. It's got to be a PNP. So the only PNP transistor, small signal transistor rattling around was a 2N3906, which is a very common in America transistor. I'm going to turn on this light in just in case this helps. It might help light up things in here. So you've got your PNP transistor where you take the emitter of that and you tie that to the 4.5 volt positive rail. The base connects to that resistor on the other side of the cap, which is pulling the base down towards ground. But transistors are current devices, so that was originally matched to the original 1960s PNP transistor, which we don't have. It was probably a germanium PNP. At any rate, this is a silicon PNP, and you take the collector out, and it's going to go to this relay. Now, this is a very special relay, something that TOMY had to make themselves. It's got two coil windings. The first coil winding is for running the relay switch. So the collector goes to one side of that coil, the other side goes to ground. So what's going to happen as soon as you turn the switch on, because this resistor is pulling the base down and your emitter's tied to positive and it's a PNP, this transistor is going to be on. So this relay is going to energize, which means the common connection on the switch on the relay is going to be sucked down to the normally open position. So nothing's going to happen as far as the mouth or the light in the head or anything like that. It's just going to be sitting there waiting. A lot of this is kind of based on the same circuitry that they used in their Radicons and their Sonicon robots, which I've kind of covered in depth before. Basically, this being a DC relay, it likes to see direct current. If you start putting AC into it, then the relay itself will start to chatter or flutter or even release altogether. And that's what they're counting on here. So when there's no sound happening, and this transistor is turned on by this pull-down resistor, the relay is on, so nothing's happening here. But as soon as it picks off the signal through this capacitor from that carbon microphone on the base, that starts superimposing itself onto the base, which means it comes into the collector, which means you no longer have the DC for this relay. So instead of staying latched down, it'll either start to chatter or it'll release altogether and go up. See, it's normally non-powered mode would be this common connection to the normally closed. And so when it hears sound, that's going to swing up to the normally closed, which is going to provide the 4.5 volts up to the light that's in the head of the robot and to the solenoid that's up in the head of the robot that opens the mouth. And both the light and the solenoid then have a common to ground. Now, how do you get the sound out of the speaker? Well, they added a second set of windings onto that same relay, which is what makes this a very special relay. And so they're using it as an audio transformer as well as a relay. So those windings off that then go directly to that speaker and drive it. This transistor configuration, which is basically it's a Class A amplifier, which means it's always on, it's always drawing current. It's not a push-pull AB or anything like that. Okay, I think we kind of covered that. Maybe I could get a little closer and show you some better images here. Try not to knock the microphone on the floor. So here you can see that copper winding, the top of that solenoid, which is for the mouth. And this right here is the light bulb. And they come down. Here's the relay, the speaker. And all the ugliness down here is basically just two resistors, the transistor and the capacitor. Back on the front side, if you get one of these that's still working right, the mouth should be normally closed when there's no power, and it should only open when it gets power to that solenoid, because basically the plunger is spring-loaded. It's pushing it up, and when power is applied, the plunger is pulled down to open the mouth, and then the spring, which I think we can see right back in there, there's this piece of metal that stops it, and then there we go. You can see that in the plunger and the spring, which is pushing it. So that's what's going on there. Let's turn it back on with a close-up going on here. test, 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 test. See the relay move? Test, test, test. 1, 2. Test, test. Like I say, in the bottom you just have your 3 D-cell batteries. You have these coaster wheels. It's not motorized, but they did put a clicker on this one wheel. So if you pull it, it should click. And the microphone cable also becomes a pull toy, or pull cable for the toy. And that's what's inside the mic robot and how it works.